Welcome to the Orange Next podcast series.
Welcome to a new episode of the Orange Next podcast series. My name is John Coat and I will be your host and moderator of today. Today in this podcast we are going into AI in process and chemical industries. And to talk about this subject I have invited Thomas Fruse. Thomas, may I ask you to introduce yourself, who you are and what you do?
Hi John, many thanks for the invitation. I'm the CEO of the company Atlantex Systems in Germany, a leading company for advanced big data analytics and real-time optimization. I'm a chemical engineer by training and the chairman of standardization committee Big Data at VDI and have been working in the field of process data analysis and process optimization with real-time optimization concepts for almost 30 years.
That's a long time. So a pleasure, welcome to the show today. Optimizing production asset by building the plant of the future is an opportunity to create a resilient and sustainable future. To give some background for the audience, Thomas, I just wanted to start with the first question. Can you give me some insights on the typical manufacturing operation principles and their improvement opportunities?
It's difficult to differentiate, but I think one model is that you can say you have some different processes. Let us think we have three types. One is asset intense production. That's a mainly interesting environment for our activity. That means you can optimize sometimes only 1 or 2%. You can save a lot of money in this area because you have a lot of energy involved and a lot of raw materials. And so it's easy to save money and to increase the level of automation. Second is machinery intense production, and you can see the limits between these both areas are liquid, so it's not easy to say that's this and that's the other one. Machine intense production, its typical environment is discrete manufacturing of things, screws, nails, whatever you are doing. This environment is mostly highly automized and very formal. The procedures are very formal. It's not so easy to optimize, but again, the limits between are not very clear. You have area that's between this. And the third, for me, the past is a people intense production. That means you have a type of discrete manufacturing. A lot of things are manually driven. A lot of labor activity is involved. And that's not so easy to optimize because you have no clear data about that. But I think the future will be that this level will go more and more in the direction of asset intense or machine intense production.
Is there also a hybrid form between Azure intense and machine intense production?
Yes. Very often, for example, if you have a raw material like plastics, you have to mix the plastic with some ingredients to make it stable, again, light, for example, or to colorize. And then you go in a machine intense production because you are pressing some forms with the plastic. In that case, you have both. You have this asset intense production and some machine intense production in one stream. And you have to find the variables you can adjust to increase the amount of money you can make with this. I think the amount of money is the most important point.
Optimization of these processes is mostly linked to the terms Industry 4.0 and OPEX 4.0. Could you provide a brief explanation on those two items?
Yes, Industry 4.0 is a more artificial word. We speak about digitalization or digitation and Industry 4.0. Industry 4.0 is now defined, and that means that's a very systematic approach, a multi-stage concept you can go through. What we have done in the definition of these words is we have differentiated between the normal digitalization. Digitalization means automation of processes, and you add some measurements and you build a network between these computer systems or DCS systems. And Industry 4.0 means that you go more in a holistic direction. And the first step is that you have to bring all the data of the different machines and units together in one database. We speak very often about a single source of truth. You have one database, and that's a single source of truth. You have all information in that. And if you have done this, you can start with a analyzing phase, and this analyzing phase we call OPEX 4.0, Operation Excellence 4.0.
Yeah.
And if you look to a standard OPEX procedure, that's a little bit like Lean Six Sigma. You try to understand how the operator will work and what's the outcome. That's a more qualitative way to handle things. And what we are doing in the Industry 4.0 is we try to make it mathematical. We try to understand with statistical correlations between the variables what will happen if you do a specific action. And that's the difference. And that you can do with, come back to the single source of truth. If you have this one database, you can extract the data from the database and you can learn from the database. And then you know exactly what will happen if you change something in the process. And that's shortly OPEX 4.0. It's a part of Industry 4.0. And to close this explanation, the last steps of Industry 4.0 means step one is you build a model from your process. You use the data sets from the single source of truth. You make a model, and the model will give you a deep understanding. And then you can use the model to make a closed loop, to automate the process. You can use the model to find every time perfect set points and bring it into the process, and then you can save the maximum of money.
Got it. Could you elaborate on how big data, or how you call it, the single instance of truth, and AI take you to the operational excellence to the next level? Because I can imagine that could really help exponentially grow to a next level.
Yes, the next level is given by evolution of mathematics. That means in the past, people has used some statistical approaches, and now we will go with algorithms like machine learning. And these machine learning algorithms, they can bring you really a deep understanding about the behavior of a process, and they are able to handle many variables. And a typical production process has very often hundreds of variables, and that you have to grab to understand, and for that machine learning is perfect.
Perfect. Yeah. And can you also provide some what kind of type of industries you have worked helping customers going in this industry OPEX? I can imagine a lot.
We have seen nearly 1,000 projects. And
30 years. So.
my main industry, my home, you can say, is the chemical industry, but we have seen many projects in power generation, in refineries, oil refineries. Food is another area we have worked with, and we have many examples documented that are plants like ethylene oxide, methanol, ammonia, polypropylene, polyethylene, superabsorbents, but oil and gas, steam, power, pressed air, all these things are a part of the projects we have done in the past.
And can you take us through the experience, what you have to deal with these customers, helping them further in this journey?
Yes. The most of the customers are not very well experienced. That's what we see in the market.
I see the same thing.
Yeah. The problem is very often that the quality of data is not very good.
Exactly.
Because they have collected data without any idea. And you know, if you are doing things without a target, without an idea, you will forget something. And that's what we very often can see in industrial processes. And then we came around the corner and we say, hey guys, we need this and this and this variable. And then they say to us, sorry, we haven't measured that, or we haven't saved that into a database, that we see very often. And if they have saved this variable, the quality is not really good, especially if they have taken manually probes and analyzes. That's a big problem we see very often. And so we have to guide them step by step through different levels of maturity. And maturity is a good word because we are working with a maturity index here with the maturity center in Germany on the Aachen University.
Right.
They have a structured approach that you can measure the maturity of a customer by doing this journey.
Okay.
And that are back to the Industry 4.0. We have seen we have different steps you have to go. Automate, network, visibility, predictive operations. That means you build a model, prescriptive, autonomous, that we have discussed before. And that are the steps you have to guide your customer through a long journey. It's not easy to do.
So the maturity index is, let's say, a program where you can really say, okay, you're in this level of maturity, and I can give you guided advice on the level of maturity that you have, so that it makes them faster to accelerate in this journey.
Faster and more clear. They get a plan, you can say, what I have to do at next. And we give them a first idea how much money you can save by doing all the steps.
Yeah. I can imagine. So shifting some gears, now I wanted to talk about the challenges in this domain, because I know innovation and digitalization in a very conservative world called manufacturing, process manufacturing, can be challenging. So can you elaborate on some of the challenges companies have, why they don't uptake these new technologies and associated opportunities it could bring, and also maybe what are some steps that they could take to undertake this journey?
I think that I have described very good by this step-by-step approach in the Industry 4.0 discussion we had. I think the biggest problem that people have is a wrong mindset. That's the most important point, because let me give you an abstract picture about that. My understanding, if I have a good practice, if I produce something, I know all the parameters what have influence to my outcome. And the outcome is the cost of the piece or the kilogram of substance I will produce. And the outcome is the quality of that piece I will produce in my production process. And I have to know all the influences, all the influencing parameters. I have to know and I have to record them. And I have to show that if I do everything the same, I will get the same result. So it's easy to understand. There's no magic behind, and that you have to bring into a database. But to bring the people to this level of understanding, that's not easy, because sometimes you hear words like, oh, that we have done in this way since 20 years.
Yeah.
But that's not helpful.
Yeah.
You have to change completely your perspective to this Industry 4.0 view to the things. And what you have to do is you have to clean up your production. That's very simple, but not simple to understand for the most of these people.
And what do you mean with clean up your production?
Yeah, with clean up, I mean that you need a very clear picture about what are the causes and what are the effects. And you have to bring all these parameters into a database. You have to measure all these parameters. And that's a procedure like cleaning up your processes. Because up to now, the most processes are very often driven by the feeling of people, by doing things manually, by looking, oh, I have the feeling I have to go to 70 degrees Celsius. But that's not useful if you would like to automate your process and to go in this Industry 4.0 level. And that's necessary to use, for example, machine learning to understand the correlation between changing a parameter and saving energy, for example, or saving CO2.
Yeah. So what, if I got you right, so the data quality is therefore corresponding poor in some of the cases. That's why they have that mindset still in the past. They really need to rethink, to polish up their production, of what you just said, to clean up the production. And therefore they never come to the state like, oh, from this data we can create this predictive model and go to they even not are thinking of, oh, we can do real automation, autonomous driving of a factory plant or production floor or whatever.
And to tell you a strange story, at the end, if you have a good digital twin, we have a good model.
Yeah.
Then you can give us a target function, a mathematical target function, and this target function will give to the automation system at the end the direction where it should go. And now I had a discussion with a plant manager. I've asked him, what's your target function? And he had said, I would like to save money.
Yeah.
Then I have said, okay, switch off your plant and then you save all the money.
Yeah.
No. I would like to produce. Okay, let's re-talk about the target function. And that's a typical discussion we have very often in interaction with the customer.
Yeah, yeah. And can you elaborate a little bit on those kind of AI-powered application, if I may say that like that? Some typical, like the prescriptive operation that you just mentioned. So creating instructions from data. What typical AI-powered application do you see in the markets that you have served or the customers that you have served over the 30 years?
Yeah, you can say that are the typical targets what a controller is interested in, like energy efficiency, CO2 saving, throughput yields, profit optimization, maybe advanced assistance. Sometimes you have a situation, you have 30 machines and 30 guys who are driving that machines, and you say, hey, I'm interested to have one guy who can drive 30 machines. That can be a target. And the way how it works is very simple. You make a model, and this target, I have told you, is the output parameter. And then you can ask your model what I have to manipulate, in which way to come to that target.
Yeah.
That's what will happen in this environment.
Yeah. So those various AI-powered opportunities applications that you just mentioned, like CO2, yield, energy savings.
Yeah.
Those are all created to optimize the performance and the turnaround times of the customer. So I can imagine that generate an enormous impact per installation, especially if you're talking about energy. It takes a lot of energy to produce something. So if I hear this, I really want to know what is needed in order to get started. I know this is an easy question to ask, but maybe harder to answer for you, but maybe not. So, but maybe you can briefly touch on it.
Yes, I think there are many documents available. You can get a little bit background information. And a very good document you can find is this maturity index from the Architect Foundation.
Okay.
It's very important to say that's a foundation, not a company. That means they have not the aim to sell something to you. It's very interesting to read. You can put that link, I think, in the description of the podcast. The people can read that document. There are many sites. It's very interesting. And I think you get a very clear picture about what they mean about this process of Industry 4.0. Then we have a paper, for example, on the VDI, the German Engineers Association, that's called Opportunities with Big Data, Best Practice. And that will give you a picture how to work with the data.
Okay.
So the first step is maturity index. That's the first. You have to prepare your environment for that. And then you would like to work with big data. You can go in this VDI document. And background information is we are finished now with the standard VDI 3714. That's a big brother of this paper you can download in VDI. And we are working to bring it in the ISO, to an ISO standard. That's what we are doing at the moment. Together with TÜV Süd. It's a very big activity. And we would like to establish a training procedure for people that they can be certified to use these procedures. So you see, we are doing a lot of things to bring the people to a right level to understand and work with this technology.
Very good. Anything else to add?
Yeah, we have some partner companies like ICT, your company. I think we work together with ICT. That means if you have a connection to ICT, Arthur D. Little is another company, TÜV Süd is another company. You can ask them and they can help you to guide you through the process. And we as Atlantic, we are available too. We work together in a big network of partnership, and that can be helpful to support this journey.
Very good, very good. So I will share the links. No worry about that. I have them already received, so I will put them in the podcast so everybody who's listening, you can read them through. So we are wrapping up this conversation, a lovely conversation. So I still want to know, what is your key takeaway? So people that I have listened to this podcast or watched the podcast, what is your really key takeaway that they need to get along with this podcast?
Yeah, the key takeaway is that we haven't another chance than to go in this direction, because we live in a time with a increasing price pressure. That means the efficiency of production has to be increased in the next years.
Yep.
And that's a question of the survival of companies. The other point is the constraints regarding CO2 will be more and more restrictive, that we will see in the next years.
Yeah.
And in my opinion, there is no better way to go in this positive directions than using Industry 4.0, because that's a very effective way to go in this direction. And you haven't to invest in physical assets. That's a brain technology. You have to use your brain to make the right things. And that, I think, is a very good way to handle the actual problems we have in our time.
Very good. So this has been a great conversation, Thomas, but we need to wrap it up. So thank you so much for taking the time to share your story with the people watching and, of course, hearing afterwards. On behalf of Thomas and myself, thank you very much for your time and your attention. And see you next time on a new episode of the Orange Next podcast series.
Yeah,
Bye-bye.
thank you, John, for the great opportunity. And yeah, bye-bye.
Bye-bye. Bye.
Thank you for listening to the Orange Next podcast series.